I have a love-hate with this section, okay? It's a lot of work on the front end to set it up, but then I can answer a lot of questions really quickly. The other thing is, it's time consuming to get it set up. And pros and cons. Do I think one method's better than another? I don't know, I can't really say that, but I like to kind of show you how to evaluate trig functions using the unit circle. Not drawing the triangles. Not doing opposite over hypotenuse, adjacent over hypotenuse, etc. So just another way to do it, and like I said, there's a lot of setup here on the front end. So get ready for it. So you can see, of course, we're going to be using the unit circle here today. But you can see there's a couple circles on your notes. We are going to be drawing and filling these in, and we all know my artistic skills. It's really going to be super great. So don't forget here just a few things. Relationships between your trig functions. This is all in the blue box on mine. It's all on your yellow sheet too. For instance, of course, cosine is 1 over secant. Tan is 1 over cotan. They're just the reciprocals. They're flipped. We already know all of that, okay? We're going to be using that today. Now, what other is important here is really these first two. Because if I can get sine and cosine, I can get you any trig function out of the 6. Because remember, on your yellow identity sheets, tangent is sine divided by cosine. Cotan would be the reciprocal. So long as I can get sine and cosine, I mean, I can just let it rip and get you all 6 in the blink of an eye, okay? Now, to do it on the unit circle today, without the triangles, which I'm going to draw a couple triangles just to show you the relationship because I can't help myself. So notice sine, it says equals y, cosine is x. So we know this. When we looked at these ordered pairs for our quadrantal angles, like that was 0, -1, we knew cosine came first, sine was second. Alphabetical order. Same rules today, just a little reminder since it's been a while. So we're going to use the coordinates of the point instead of opposite hypotenuse, adjacent hypotenuse, all of that good stuff. And of course, because we're using the unit circle, sometimes they reference these as circular functions, just for whatever excitement that is for you, their little terminology. All right, we're going to try to, my drawing skills, divide that first circle into 8 equal arcs here in a second. Let's just remember on our unit circle, we have our radius of 1. And back to our geometry days, the circumference of a circle, remember, was 2 pi r. R is 1. So 2 pi times 1, I'm just going to put 2 pi, of course. Okay, so it says divide the circle into 8 equal arcs. So I kind of gave you the picture of the circle just to make your drawing a little easier here. So of course I'm going to mark the center in here, trying to mark the center, and I'm going to draw my x and y axes. Square it up here. Pretty good. There's x, of course, and y. Every time you hit the point, you know. Okay. So you can see right now I have 1, 2, 3, 4 arcs. We want 8 arcs. So I'm also going to split up each of these, so I have a total of 8. Now, are they going to be equal? No, you know my drawing skills. Can't be good at everything. All right, so we have 8 equal wedges, 8 equal arcs. Now, I'm going to label a course in degrees first, just because that's always a little bit easier. Now, remember, our full circle is 360, and we made 8 equal arcs. So punch in your calculator, maybe just now, 360 divided by 845. So remember when we started drawing our angles, of course, we start over here in the positive x-axis, and then I'm going to add 45, and just keep adding 45 and keep going around the circle. So 0 plus 45, of course, there's our 90. If I add 45 to 90, I'm at 135. 135 plus 45, 180. You know that's 180. Plus 45, 225, plus another 270 down here, 315. Wait till we have to do 12 equal arcs. That's really going to be good stuff. Now, what is the purpose of all of this? Because I don't want to make your picture a big giant mess, okay? I'm just going to kind of, I'm not going to get crazy. I'm just going to kind of redraw it all. Just watch it, because you'll see the pattern, and then we'll mark it. So of course, so I'm not going to put them all on there, but let's just mark out the first 45 degrees. Now in the past you would make your right triangle, you would label the sides. What are the sides on a 45, 45, 90? 1, 1, square root of 2. Okay, here's the connection. We are on a unit circle. The radius should be 1. If you look at my green triangle, what's the radius? Square root of 2. So here's where I got to do a little mental math. I'm going to scale this triangle, meaning if I want to turn that into 1, because I want the radius to be 1, I'm going to divide it by square root of 2, which I would do to everything. It's really fun. So if I redraw that triangle out here, so I just don't have a giant mess on it. Now, I can't, the 1 over square root of 2 freaks me out too. I'm going to rationalize it. So, this is so much more. Okay. What is this boiling down to? If we look at our point on the circle, the ordered pair, x, you went right square root of 2 over 2, and then you went up square root of 2 over 2. The cos of 45 is square root of 2 over 2. The sine is square root of 2 over 2. I find that incredibly time consuming. For couldn't I just in a little, opposite hypotenuse, adjacent hypotenuse, and cranked it out in a second? Yeah. But if you see, if you flip the page, we're going to create this. And you get it all labeled. I mean, I know, it's going to be fun. We're going to be making that big circle from scratch. I know you're very excited about that. Once we get it all made, I can answer all these trig functions in the blink of an eye. So I'm going to go back to this now because I didn't want to make it a big mess. And of course, if we made our triangle here, which I drew on the next slide, we went right square root of 2 over 2 and up square root of 2 over 2. So I'm going to label that point, that ordered pair, square root of 2 over 2, square root of 2 over 2. So that's just me copying my long, drawn, obnoxious triangle, which we could have answered all the stuff really quickly. But here we go. Now, ordered pair at 90. That's easy. Remember, radius 1. That's our standard 0, 1. Now, 135. Work smarter, not harder. Remember, if we, and I'm going to erase it, make a right triangle, we'd have the 45, 1, 1, root 2, all of this stuff. And I'm like, oh God, what is it? I'm not going to freak out about it. We're going to think about geometry and reflections. Because of course these are all, notice, multiples of 45 on purpose. Because it's all that square root of 2 over 2. The question is positive, negative, etc. Well, if I want to get to this point, we go left, negative, and up, positive. So negative square root of 2 over 2, positive square root of 2 over 2. Because they would all make your little 45, 90 triangles. Okay, we can do this guy. That one's easy. Unit circle, radius of 1, so that's just our negative 1, 0. We know that. Okay, 45 again. So I'm not going to redraw the triangle and freak out. I'm just going to think we'd have to go to get to this 225 point. Left, negative, down, negative. So negative square root of 2 over 2, negative. 270, we know that point. We went down 1, so 0, negative 1. And then to get to our last point here, we had to go right and we'd go down. Positive, negative. So positive square root of 2 over 2, negative. And of course at 0 here, you're at 1, 0, right 1. So, like I said, I have a love-hate with this. I love-hate with it. I love it because I like the quick, the relationship, the root 2 over 2. And then I'm like, man, you want sine in 135? Got it. You want cosine of 270? Got it. You want tan? I'm going to divide it. Tan of 45, sine over cos? Got it. I can answer a million trig functions in the blink of an eye for you. But is it time-consuming to draw this out? Yeah. And have we even started to talk about 30, 60, 90s? Yeah? No, that's the second circle, second one. Okay, divide it into 12 equal arcs. Because what's 360 divided by 12? Yeah, so this is going to give us all the 30, 60, 90 points. Okay, here we go. Let me try to square it up here for the center. And I'm going to draw, of course, x and y, just like the last one. So I've got 4, well, kind of equal, not really equal, 4. We need, of course, 12. So I'm going to have to put 2 more. So I need 3, 6, 9, 12. So there's 3, 6, 9, 12. All right, same thing. I'm going to start with the easy stuff. Our 0, here's our 90, our 180, the 270. So let's just write now, those are the same 4 points over there. The 1, 0, 0, 1, negative 1, 0. Okay, same stuff. Now, so I don't make a giant mess on your picture, okay? That's my drawing skills. Let's talk about if we draw 30 and what the sides on the triangle would be. One that touches the edge there. So there's 30, and we're after that point, of course. Well, old days, last semester, we make our triangle opposite the 31, opposite the 60, hypotenuse. But we want the unit circle. I want the radius of the circle to be 1. So I'm going to have to divide everything by 2. So now when I look at my point of 30, we would have to go right square root of 3 over 2, and then up a half. So I'm going to click it back a slide, and I'm going to label for my 30. I went right square root of 3 over 2, up 1 half, because I had to make the radius of 1. So square root of 3 over 2, whoops, too far. Square root of 3 over 2, and up a half. Now, let's work smarter, not harder, right? Let's do 60. We'll label that one in black. What do you think is going to happen to the sides on 60? Elliot?
The longer side is the shorter side, the shorter side.
Yeah, they're just going to switch locations. Just because if we were to draw it, so let's make our 60 opposite the 60, opposite the 30. But you want that radius to be 1, so you'd have to divide everything by 2. So now you go right a half, up root 3 over 2. So they flip ordered pairs. Okay. Now, I mean, I could have drawn like 10 triangles by the time I've gotten these 3 points on here. That's why I say I have a love-hate with this section. Okay, now let's again, we're going to work smarter, not harder, right? So usually what I do here is kind of my little cheat way for it. Once I get like quadrant 1 done, I can kind of do the rest of them off reflection, so to speak, okay? So meaning, okay, so if I were to reflect this 60 point off, remember we're going up by 30 here, so that would be your 120. That's going to be 150, 180, 210, 240, 270. We're adding 30. I'm going to keep labeling in a minute, okay? But easy. We're reflecting over. So if you're reflecting over your y-axis, so to speak, x becomes negative, y stays the same. So that's a quick, easy way to generate semi-drawing a million triangles. Now, I'm going to label the next one, of course. We had another 30, so we're at 150. And I'm going to reflect at the red dot. So again, we're going to flip it over, so x will become negative, y will still be a half. All right. I'm on a black dot now, so I'm going to add, of course, 30, so I'm at 210. Now, same thing, we're thinking about, I'm just going to add them all. Let's just label them all and be done with it here. So 300, 330. Let's just get them all labeled and be done with that. Okay, so let's keep doing with our ordered pairs here. So I'm taking a look at my 210. I need the point. Well, I can reflect this 150 over it. So you'd still be left negative root 3 over 2, but the half would become a negative. It goes from positive to negative. My arm's starting to hurt writing all of this. I can do the same from the 120 point to the 240. I can reflect it. So the x is still negative 1/2, but the y is going to go to negative root 3 over 2. Hopefully you have enough room to write all this good stuff on here. Okay, same for your 300. We can just reflect your 60 point. So you're still going to be positive 1/2, but your root 3 over 2 becomes a negative. I feel like this looks like a foreign language. I don't care. Okay, 330, I'm going to reflect the 30. So you're still going right, so positive root 3 over 2, but the half becomes a negative. Isn't this fun? So fun. Now, I feel like I could have drawn a lot of triangles in the time it took me to get all of this shenanigans written up here on the board. I shouldn't keep ripping on it, okay? But the perk is this. Perk is this. Now that we have it all, I mean, I can tell you the sine, cos, tan of anything by just looking at these points. Because remember, the ordered pair, the first coordinate of the ordered pair is cosine, second ordered pair is sine. I can get you anything you want right now if you ask me for it. Now, to make your lives easier, or to try to help your cause here a little bit, let's get rid of my drawings. Here is, take a look at this nice computer generated picture, not my hand drawing, where it has everything for you. You're welcome. I like you. Okay, so you can see it's got your 30, your 45, your 60, your 90, everything on there, all of the ordered pairs on there. So let's talk about what's going to be the expectation, because of course that's always the question when we take a test. The expectation is, you're going to love me, you're really going to love me. You will get, and I'm going to give one of them to you tomorrow to do it, pretty much a shrunk down version of this. So it's going to have the circle and everything laid out for you. You are going to have to label everything. But remember, don't give me the panicked looks, because I promise it will get easier. Every year I have some kid that just tries to like memorize all the points, and I'm like, that seems traumatic to me. It's very traumatic. I get the first quadrant, I'm trying to face your side. I get the first quadrant figured out, and then remember, it's just reflections. Flipping them over, flipping to the right. So it's just changing the positives and negatives. So you are going to have to fill this in when we get to someday of a test. I know you're really excited about it. Now, once we have this lovely picture, and notice, all the radians are on here for you too, just in case I give you the angle in radians. Do I care if you convert degrees into the radians or vice versa? No, I do not care, but everything is on the picture here for you. So here is the pro of having the circle, I guess. I really don't have a lot of work for all of this to do. So negative pi over 4. Well, for fun, let's convert it into degrees. Or you should know it. What's pi over 4 in degrees? 45. So I'm going to flip back to the circle. Remember, now this doesn't have negatives on it. We're not going to freak out. Negative just means we rotate clockwise or down. So to go from 0 to negative 45 is going to land you right here. So it's asking you for the point. It's just asking you to write down the ordered pair to that point. So I'm just going to flip the slide here and write down square root of 2 over 2, negative square root of 2 over 2. And just for dramatic emphasis, of course, clearly I picked this one because it's coterminal, add or subtract 360, it's coterminal to your 315. And plus that is 45 degrees between 0 and 315. You're rotating that way. And I'm looking, and a shortcut, I'm like, well, 45, I need the one with the root 2 on it. So just a quick look, I knew it was that point because that's the root 2 one. All right, 3 pi over 4. If it helps, think of it in degrees. What's 3 pi over 4 in degrees? Actually, we don't need it. It's on our circle. Maybe. You need longer arms. 3 pi over 4. There's our 135. All we have to do is write down the point. Negative square root of 2 over 2, positive square root of 2 over 2. See, easy. Now it's easy. Okay. You might want to put this one's not on the picture, because it's negative. So let's convert it. Do your 180 over pi. How many degrees is that? negative 150. Now, just because, you know, the love of review, I can't help myself. Our picture doesn't have negatives. Can I rotate clockwise and figure it out? I mean, sure, I sure could. Or if you're like, oh, I just want to look straight off the picture and get it, do a coterminal. Just add 360 to it. Add another circle that lands you in the same spot. 360 minus that, we got 210. So I'm going to look at the picture. I'm looking, of course, for 210, 7 pi over 6, and I'm just going to jot down that point. Negative root 3 over 2, negative a half. So that's just first kind of getting used to looking at the points on it. Now, still easy, I promise, this is the easy part of this. Now I'm just like, oh, if I want the cos, the sine, the tan, the cotan, we can actually make all of that off our ordered pairs. So, find the 6 trig functions for the value t. All 6. Yay. Okay, pi over 3, which of course we know pi over 3 right here are 60 degrees. I'm just going to first write that point down so it's in front of us. So 1/2 square root of 3 over 2. I'm just going to jot it down. 1/2 square root of 3. Got it. Now, right there you have 2 trig functions. Cosine is the first coordinate. Sine is the second. And remember, from these two, I can get you anything you want. I'm going to go tangent next. Now, might be a little rusty on it. Look on your yellow sheet under quotient identities. Remember, tangent is sine over cosine. So I'm going to divide these out. Well, we know if you divide 2 fractions, we multiply by the reciprocal. So I'm just going to go straight to that. Multiply by the reciprocal of 1/2, 2, and we end up with root 3. And to get the other remaining 3, remember, it's all reciprocal work. Reciprocal of cosine, we would need secant. And the reciprocal of 1 over 2, 2 over 1. I'm going to do sine. Reciprocal of that, I'm going to flip it, 2 over root 3. I'm like, oh gosh, I got to rationalize. Okay, 2 square roots of 3 over 3, whatever, will work, got it. Tan matches up with cotan. And of course, I need the reciprocal, that's over 1, so 1, that's an equal sign, 1 over, and then I'm going to rationalize. So, I think the unit circle is quicker than me actually drawing the triangles if I'm provided this and can just look off it and steal the points and crank them out. But if you have to make all of that from scratch, it is a little bit on the time-consuming side. Okay, pi over 2. We all know pi over 2, 90 degrees, one of our quadrantals. Hopefully we know our point for 90 degrees up there at the top, 0, 1. Let's jot it down and crank them out. 0, 1. Okay, so once you have those, of course, you could get anything. We need all 6, but we can get them all. Cos is 0. Sine is 1. Remember, it's always alphabetical order too, C, comma, S. Tan, we're going to divide sine over cosine. 0 under the line is what? Undefined. And now, of course, we need the remaining 3, the reciprocals. Well, that's easy enough. Okay, cosine goes to secant. Now, reciprocal is 0. You might be like, 0 is technically in the numerator. I would have to put it in the denominator. So what's secant? Secant 1 over 0, which is undefined. 1 over cosine. All right, sine goes to cosecant. Well, that's easy. Reciprocal of 1 is 1. 1 over 1 is still 1. Okay, and then let's do cotan. Well, if I do the reciprocal of 1 over 0, 0 over 1. Got it. So, still time consuming. Okay, last one of these guys. Negative pi over 6. Or, if it helps you, negative, of course, 30. So, I'm going to flip back to the circle. Let's make sure we pick the right point. One more. Negative 30. So which point, what's your ordered pair that you're looking at? Negative 30. Is it the first one, second, or the third? Negative 30. What is negative 30 coterminal to, if that helps the cause? 330. So we're looking at the first point here. So I'm going to jot that down. Root 3 over 2, negative a half. One more. Root 3 over 2. So of course we know cosine and sine. Yeah, I can do the reciprocals. I'll get to it. Let's get tangent while we're at it. Now we've done it enough. We know it by now. Tangent, of course, is sine divided by cosine. But divide. I'm going to go right away to multiply by the reciprocal. So I have negative 1 over root 3. And of course, we gotta rationalize. All right, let's do the reciprocals. And we're done with the obnoxious part. Okay, secant. So I'm going to flip root 3 over 2 to 2 over root 3. I'm going to rationalize it. I'm going to do the reciprocal of sine so I can make cosecant. Negative 2 over 1. Negative 2. And then I'm going to do cotan. Now, work smarter, not harder. I'm going to actually look at this fraction here for tangent before I simplified it, because the same thing, just a different form. I'm going to do the reciprocal there because it's less work for me. Negative root 3 over 1, which is that, which saves me doing some simplifying. How fun is this? So fun. Now, I will tell you this. On your homework, the first thing that's on there, or the first thing, there is like the blank circle and it wants you to fill it out and label it. Am I going to know if you just straight copy that? I'm not going to know. I mean, I've got a lot of great skills, mind reading, not one of them. But again, just prepare yourselves. You are going to have to be able to make this or fill this in when we do get to a test date. So we're going to practice it tomorrow, so get yourself ready for that. Okay, now it's easy. Use the calculator to evaluate. All right, question. What's your mode in? Degrees or radians? I like the, let me ask you this. Do you see a degree symbol on this slide anywhere? Sure don't. So we got to make sure we're in radians. No, okay, so let me pull up these are, I mean, nothing fancy, just straight type them in. It doesn't say what to round to, so let's see what we get, I guess. All right, I am in degrees. Better check it. I'm going to put it in radians. Never know on this thing. Sine 2.2. Got it. Doesn't say what to round to, so surprise me. There's my answer for it. Screenshot action. Cos of 1.1. Let's type that in. Bless you. I think that was a sneeze. Round to whatever you want. It doesn't say. Okay, how are you typing in cotan of 28? You can use your yellow sheet. Cotan is the same as 1 over tan. Or you could do tangent inverse if you want to get fancy about it. So I'm going to do 1 over tan, 1 divided by tan, 28. That's what you get. Or, of course, just to be fancy, just to show you too, you can, because, of course, tan is the inverse of cotan. You could hit tan of 28. Whoops. Maybe. I hate this thing. I swear. I get so mad at this. I am hitting clear. Do it. Oh, did it freeze? Oh. Did it freeze? Uh-oh, kids. Uh-oh. Oh, it froze. Well, at least it got off the screen. Okay, the other way you could type it in, I'm just going to tell you, is you could do tan of 28 and then hit the inverse key. The inverse key is on that left-hand side. It looks like x to the negative 1. That means the inverse. The inverse of tangent is cotangent. So that's another way to type it in, or just do your 1 over tan. You get the same answer. All right, home stretch, people. Home stretch. Okay, last thing I have for you. This is just to show you. Okay, because as you can see, that third group of identities on your yellow sheet, odd and even, we're going to start using those. They're going to start coming up more and more, especially the next chapter, so we're just kind of previewing a little bit here with the different identities. We haven't really used them yet. I just want to show you, talk about them, how you can memorize them, because eventually you're going to have to do all that. when we get to it. So functions even, you replace x with a negative x, you get the exact same function. Odd, replace x with a negative x, you get the opposite. In math, we show that with a negative. So at some point, not for a while, you will have a very lovely little quiz over all those identities on that yellow sheet. You're going, I know, some cases. In my trig pre-calc classes, they're taking one this week over the whole front side. So we do work on memorizing those. So the odd even ones, here's how I memorize them, or how I got it down. So for odd even, if you read the sine, cosecant, tan, or odd, cosine, secant, or even, I really memorize this part. So I look for, because it's less to memorize, only 2 of them, I memorize cosine and secant or even. So I'm looking at these. So what happens when you'll have this identity quiz, which isn't for a while, obviously, I'm going to give you the left-hand side, and then there's going to be a blank for you to fill in the right-hand side. So I just remember, I look through the 6 of them, I'm like, okay, where's cosine, where's secant? It's just the exact same original function now. There's no negatives on them, it's just the original function. The rest of them, then I just remember the rest of them are odd, so the opposite. I have to throw a negative in the front of all of those, and then write down the trig function. So again, we're going to practice all of this. I know it's so exciting, all the stuff I've thrown at you today. We will be practicing and working on these. I'm just kind of prefacing a little bit with it for you today. That's as far as we're going to take it. Today, the hard part is going to be making the circle.